What is HPLC? HPLC stands for High Performance Liquid Chromatography. HPLC is an instrument using chromatographic technique to separate mixture of compounds. HPLC is very powerful instrument used in biochemistry and analytical biochemistry because it yields high performance and high speed compared to traditional chromatography. HPLC is used to identify, quantify, and purify the individual components of the mixture. So now, let's go to the principles of HPLC. As we know, HPLC is a liquid chromatography. Liquid chromatography is a separation technique that involves the placement, which is the injection of small volume of liquid sample into a tube packed with porous particles known as stationary phase, where the individual components of the sample are transported along the packed tube known as column by a liquid move forced by high pressure delivered by a pump. When a mixture of components are introduced into the column, various chemical and physical interactions take place between sample molecules and the particles of column packing. This mixture will travel according to their relative affinities towards the stationary phase, and the components which has more affinity towards the absorbed travel slower. The component that has less affinity towards the stationary phase travel faster because the two components do not have the same affinity towards the stationary phase. The components are separated. These separated components are detected at the exit of this tube by its column by a flow-through device known as detector that will measure their amount. The output from the detector is called liquid chromatogram. In HPLC, mobile phase refer to the solvent being continuously applied to the column or stationary phase. Mobile phase acts as a carrier to the sample solution. A sample solution is injected into a mobile phase of an assay through the injector port. Usually, two or more solvents like water and acetonitrol are used for separation of biomolecules. The highly purified HPLC grade and chemically unreactive solvent should be used. Before using HPLC, the solvent should be degassed because it can cause bubbling, and the bubbles can damage the stationary phase. The selection of mobile phase also must be depending on separation components in the sample. Usually, polar and non-polar solvents are used in certain ratio. What is stationary phase? Stationary phase is the substance on which adsorption of analyte takes place. It can be solid, gel, solid-liquid combination. All of this has their own pros and cons and different usage. How does it work? The column, known as the heart of chromatography of stationary phase, will separate the components of interest by involving various chemical and physical reactions. In this table, there are two phases which are normal phase and reverse phase. As we can see, there are some differences between the usage of these two phases, mostly on sample movement and separation based on when using different type of stationary phase. There are three most common particles used as stationary phase, which are microporous particles, pellicular particles, and bonded phase particles.
The function of high-performance liquid chromatography, HPLC, is to detect individual compound within a complex solution. So what are the major components of HPLC? There are 5 major components of HPLC, so we will take a look at each component and their functions. Firstly, we have the pumps, which is to force a liquid called the mobile phase through the liquid chromatograph at a specific flow rate, which is expressed in milliliter per minute. The types of HPLC pumps that are commonly used are constant pressure pumps and also constant volume pumps. The second major component of HPLC is the injector, which is placed next to the pump. The function of the injector is to introduce the liquid sample into the flow stream of the mobile phase. Typical sample volumes are 5 to 20 microliter. The injector must also be able to withstand the high pressure of the liquid system. The simplest method is to use a syringe. An autosampler is also widely used in HPLC, which is an automatic version when the user has many samples to analyze or when the manual injection is not practical. Thirdly, we have the column. The column is considered the heart of the chromatograph. The column stationary phase separate the sample component of interest using various physical and chemical parameters. The success or failure of a particular analysis depends on the choice of a column. The fourth major component of HPLC is the detector, which is to detect the individual molecules that come out, which is elute, from the column and convert the data into an electrical signal. A detector serves to measure the amount of those molecules so that we can quantitatively analyze the sample component. the detector provides an output to a recorder or computer that results in the liquid chromatogram. The detector is selected based on the analyte or the sample under detection. The last major component of high-performance liquid chromatography, HPLC, is the computer, which is the data processing unit, frequently called the data system. The computer not only controls all the modules of the HPLC instrument, but it takes the signal from the detector and uses it to determine the time of elution, which is retention time, of the sample component, which is qualitative analysis, and the amount of sample, which is quantitative analysis. The concentration of each detected component is calculated from the area or height of the corresponding peak and reported.
Some of the advantages of HPLC is that it has high resolution power, which allow it to be used for the separation and analysis of complex mixture. Additionally, analysis by HPLC is accurate and highly reproducible. Thus, the analysis can be repeated easily to produce the same result. The broader choice for mobile and stationary phase and not constrained to volatile solute make HPLC more versatile compared to GSC in some respects. Now for HPLC limitation. HPLC requires the generation of high pressure for its operation, which is quite costly. This high pressure also enforces constraints on the HPLC instrumentation. Additionally, HPLC also takes a longer time to produce result due to its low flow rate compared to other methods. Moreover, it is not suitable for complex biopolymers such as protein. The reason is HPLC uses organic solvent that can cause protein denaturation. Secondly, large capacity HPLC columns are quite expensive. These are some solutions that can be used to overcome the limitations of HPLC. Previously, chromatography has lower pressure and higher flow rate than HPLC, but produce comparable resolution. UPSC or ultra-performance liquid chromatography has a simulation with higher resistance to high pressure and also offer better resolution than HPLC. Finally, fast-protein liquid chromatography is more suitable for biopolymers.
The process of HPLC begins with injecting the sample solution, which is the mobile phase, into the HPLC system. The mobile phase can be a solvent or a combination of water with organic solvent or even mixtures of organic solvent depending on your experiment. The mobile phase will be run through the stationary phase. The sample can be injected into the HPLC automatically by the HPLC autosampler or manually using a syringe. The simplest way is through the injection valve, which is the example shown in this clip. While in the loop position, the high-pressure eluting solvent flows directly into the column. Through the needle port, the syringe loads the loop at atmospheric pressure. Excess sample will exit the loop via a vent port. After the sample is loaded, the valve will be switched into the inject position. The HPLC pump then forces the mobile phase through the column and then detector under high pressures. The flow delivered by the pump will move through the loop, forcing the sample ahead of it to flow to the column. In the HPLC system, a vacuum pump and a degasser are connected to it. It is used to remove dissolved gases from the solvent. The pump will then drive its solvent into the mixing chamber where mixing will take place under even higher pressure.
Separation in column is based on differential positioning of the sample components between the mobile and stationary phase. The component that has more affinity in mobile phase travel faster and elute out first. The component which has more affinity towards the stationary phase travels slower and elute later. There are two types of phases for HPLC, which are reverse phase and normal phase. Reverse phase HPLC consists of non-polar stationary phase and moderately polar mobile phase. The more hydrophobic the analytes, the more they retain on stationary phase. It's the opposite for the polar analytes, where they prefer mobile phase, which then makes them move faster. Normal phase HPLC has polar stationary phase and non-polar mobile phase. The more polar the analytes, more retain on the stationary and vice versa. As the components eluded from the column, they will interact with the detector. Different type of detector can be used, such as UV visible detector, deuterium lamp used for UV detection, while tungsten lamp used for visible region detection. Light from the lamp is shone onto the prism and dispersed according to wavelength, which then shine on the flow cell. As the components eluded and entering the flow cell, bonding and non-bonding electron of this component can be absorbed energy in the form of UV or visible light. The final data will be displayed based on the software in the computer. The number of peaks present indicate how many components are in the mixture. X-axis shows the time taken for the analytes to pass through the column and reach detector. Y-axis or area of the peak indicate the number of specific analytes that present